Hi everyone, thanks for joining me. This is the start of week 2 of our Chemistry 1121 class, and at the end of last lecture we looked at those SI units. So remember there's those 7 base SI units that in theory you can measure anything in the universe. And so for instance the one for length was the meter, and we abbreviated just with the lowercase m. And here's the problem: if we've got something really teeny tiny, like a speck of dust, or something extremely large, like an elephant, maybe the meter is just too big for a speck of dust and too small for an element. And so, in the old units, right, we might use things like inches. So we might say, from here to here is the inch. And if we've got, say, 12 inches, then we can say, well, the inch is starting to look a little bit small, so we can call that a foot. And maybe we have something that's 3 feet long. We can say, well, now it's inconvenient to use feet, so maybe we should use yards. And then maybe we've got something that's 1,760 yards long, and we say, gosh, yards are really too small. How about we use miles? And so we can keep going ahead and redefining units if we want to. And the only problem is, if you look at those units, right, they're kind of crazy. To go from inches to feet, you have a factor of 12. From feet to yards, you got a factor of 3. From yards to miles, you got a factor of 1760. So doing the math in your head, keeping track of the 12s and the 3s and the 1760s is kind of tough, because multiplying or dividing by those don't give you nice clean numbers. And so we're going to use SI prefixes, which are always going to be powers of 10, in order to make the units bigger or smaller. And the reason for that is that when we multiply or divide by a power of 10, we just effectively shift the decimal point. So this is way easier. So let's have a look, see what our units look like now. So maybe we've got something that's really large, and we're going to measure its length or whatever it may be. And the regular unit is just too small. So we can go ahead and create a set of prefixes, and each prefix will typically be referred to as using a symbol. And over here, we're going to set up a table here. So this would be the meaning over here. So if you need something that is ginormous, you can use the prefix Giga. And Giga, that's a G, by the way. Let me go ahead and see if I can find the eraser and spell that a little more neatly. So Giga is Giga. Its symbol is G. And what it means is that the prefix multiplier, okay, is 1 billion. So whatever you had, you needed 1 billion times bigger. You could write that in scientific notation as times 10 to the 9. And for instance, if you ask yourself how long are you likely to live, the answer is on average we live about 2.4 billion seconds. So 2.4 times 10 to the 9 seconds. And we could write that as 2.4 gigaseconds. So if you look there, right, the 10 to the 9 we can replace with giga, and we normally just use the symbol G for that. So if we want something a little bit bigger, or actually quite a lot bigger, you can use giga. Now if we want things that are bigger but not quite as big as giga, we can use mega. Mega means you want to make it 1 million times larger. So that is times 10 to the 6. So an example of something that might be mega is the distance from the North Pole to the South Pole is from the North Pole to the equator is about 10 million meters. That is 10 mega meters. So mega means times 10 to the 6, or 10 million meters in that case there. If we look at the other prefixes, we have prefix kilo. And kilo we just represent as a symbol K, and it means we want to multiply our unit by 1,000, or times 10 to the 3rd power. So if we have a kilogram, 1 kilogram is the same thing as 1,000 grams. If you had a kilometer, that would be 1,000 meters, and so on. So if you had something like 3,500 candela, right, that would be 3.5 kilo candela. So candela was one of those weird SI prefixes we saw last week's lecture. So kilo makes things larger. Now we go on the other way when we need smaller things. So if we need a smaller unit, if we need something smaller than a yard, we can use a foot or an inch, but we got factors of 3 and 12 that kind of complicate the math. So we can use SI prefixes, those powers of 10. And I'll just kind of change my ink to blue here. We can use deci. That means we want it 1/10 the size, or times 10 to the minus 1. We can use centi and milli if we want to go even smaller. So centi and milli, or C and M. And what centi means is that that unit needs to be 100 times smaller. And what milli mean is that unit needs to be 1,000 times smaller. So in scientific notation, that would be 10 to the minus 2. And for milli, it would be 10 to the minus 3. So if we want a thousandth of a meter, we can use a millimeter. If we want a thousandth of a second, we can use a millisecond. But maybe we just need 100th of a mole, so we can use a centimole. Or maybe a tenth of I don't know, a meter, so we can use a decimeter maybe. And if you think about these, you might recognize these. So what is the tenth of a dollar called? And the answer is a dime. So this is a picture of a dime here. So 1/10 of a dollar is a dime. And of course, what is 100th of a dollar? And the answer is a cent. So here's a picture of a cent. So it's commonly called a penny, but that's just sort of a slang term for the English coin that's 100th of a pound. And then the very last one here, what is 1,000th of a dollar? And if you are like, well, there's no such coin as 1,000th of a dollar, you're quite correct. But if you've ever looked at a gas station price, you'll often see there's a point here. So this would be the $3, this would be 4 dimes, this would be 5 pennies, and you would see 9/10ths of a cent, or 9/1000ths of a dollar. And so this is the mill part right here. So banks are required to keep track of your money down to 1,000th of a dollar. And of course, if you have 10 gallons of gas, this gas is going to cost you $34.59. But if you have $1, right, it would be $3.45 and 9/10ths of a cent, or 9 mils. So we don't issue the coin because the coin would probably be worth more than 1,000th of a dollar. But it's called a mil anyway after this prefix milli. And if we go on down to even smaller things, we have micro. So micro, which has the symbol mu, so that looks like a sort of a backwards Y, but it's like the Greek letter M, so that is mu. It means that the unit you had was too darn big, so you actually wanted it not 1,000, but 1,000,000 times smaller, or in scientific notation, 10 to the minus 6. And so the average cell might be on the order of about a micron apart, about a micrometer apart. And we can go even smaller than micro, actually, so we can go all the way down. And I think in this course, we'll probably just go all the way down to nano. And what nano means is that it is essentially 1 billion times smaller. So we've gone from giga, which is 1 billion times larger, to nano, which is 1 billion times smaller. And why might nano be helpful? Well, if you looked at, say, the DNA spiral or something, the double helix, so I guess I've only got half a helix there, so there we go. It would be on the order of 1 nanometer wide. So most molecules are going to be sort of on the order of about a nanometer wide as well. So most of the things that comprise of your body, that make up the structures in your body, are made from molecules, and most molecules are on the order of about a nanometer across.